Hello and welcome to UGC E-PG Pathshala. I am Dr. Karuna Shri, Assistant Professor, Department of Geography, Kirodi Mal College, University of Delhi. Today I am going to discuss with you the module Interruption of the Cycle of Erosion, which involves tectonic, climatic and base level changes, and it comes under the paper Geomorphology. The objectives of the present modules are: we are going to discuss first fluvial system, second cycle of erosion, third division cycle of erosion, fourth rejuvenation, in which we will discuss base level changes, in which dynamic rejuvenation, eustatic rejuvenation, climatic interruption to the cycle of erosion, and fifth rejuvenated landforms. First, fluvial system. Fluvial system may be divided into following three zones. Zone 1, primarily watershed basin, and from here the sediments are collected. It is primarily the zone of sediment collection. Zone 2 is primarily involved in transformation of sediments from the zone 1 to zone 2. This is transportation zone. Zone 3 is where these sediments finally sink and gets deposited. So, this is primarily zone of deposition. In all the three zones, the interaction processes and the landforms found in different zones creates complex landscape structures. The fluvial system is influenced by various variables like time, initial relief, geological structures, climate, type and density of vegetation, relief or volume of system above base level, hydrology within zone 1 and 3, drainage network, hill slope morphology, sediment characteristics, that is channel and valley morphology, and channel characteristics of the depositional system morphology. Point 2, cycle of erosion. American geographer William Morris Davis from 1850 to 1934 was the first geomorphologist who proposed the model of the cycle of erosion. He developed a model showing sequential changes in the landform through time. On the lines of Charles Darwin, Davis tried to study evolution of the landforms as an organic form passing through the stages of youth, maturity and old. Third point is division cycle of erosion. Davis gave the most complete and ideal cycle of erosion in the most simple and persuasive way, naming each stage after the stage of human life, that is youth, maturity and old. Figure 1 shows the Davis cycle of erosion. For simplicity, he made following assumption. First, uniform lithology or mass of land. Second, considerable mass of land available, what was in effect a stable mass, which has rapidly uplifted from beneath the earth's surface due to earth movement. Stages in the ideal cycle of erosion are: first, youth stage. It comprises regions of broad and poorly defined water divides and consequent streams. The region has numerous trunk rivers and few large tributaries, which has directions of flow, velocity and erosional capability. These streams from infancy are aggressive and capable of headward cutting. They would rapidly cut downwards together with the vertical incision of the whole drainage network in due course of time, form deep V-shaped valleys of 30 degrees. On these slopes, slumping would be slow compared to the speed of the incision. The stream course is mostly irregular, marked by falls and rapids. Second stage is maturity. At this stage, the region achieves maximum relief. The area spreads over well integrated drainage network with maximum association with its bedrock and geological structures. There is deepening of the V-shaped valley. The intricate complex network of the tributaries and streams give way to more organized, well integrated network of drainage, and the streams are gentler and their velocity reduced. The base level will have reduced importance and the drainage network will have maximum relationship with the geological structure. This primarily involves removal of previously accumulated sediments from the bedrock and rejuvenation of the existing rock pediment. Lateral cutting is predominant, leading to extensive floodplains which do not generally exceed to the width of the meander belts. The valley floor is generally graded and the relief is shows progressive decrease. Old stage. By this stage, there is gradual reduction of the river gradient and velocity. The valley slopes at the sides and are massively degraded and is mostly broad, gently sloping and with broad floodplains. Sometimes the width of the associated meander belts are surmounted by slowly lowering rounded divide. The base level will have thick soil cover and the whole surface will be closer to the base level. The integration of the drainage which progressed through the maturity is complete. There are visible topographical residuals like monadnocks with general outcrops over the peneplain in the later stage. You can refer to figure 2. Peneplain can be renewed through various upliftment process which causes it to redissect. A new set of landform is formed as a result. In this process, different stages of the cycle are superimposed on one another. Figure 2 shows both youth, mature and old stages. Now the fourth point is rejuvenation. There are numerous incidences where the normal cycle of erosion have been interrupted a number of times due to various reasons. Multicyclic evolution of the landform is more common as compared to the monocyclic. In such cases, where the youthful stage of the cycle is superimposed on the old stage is termed as rejuvenation. It is therefore very rare that the landform development in a cycle is ever complete. The ultimate level to which, but not down to which, the river can lower its valley due to fluvial erosion is called base level. The ultimate base level is the sea level. The base level can vary according to the surface it is flowing on. Any changes in the base level can change the local character of the landform. It is very unlikely that the base level will not be interrupted during its course of erosional cycle. There are various reasons due to which rejuvenation happens or there is interruption in the cycle of erosion. First is base level change. The change in the base level can be termed as positive if there is a rise and negative if there is a fall, which may lead to accelerated elevation and renewed erosion. A complete peneplanation may take around 10 to 50 million years. How early or late it happens depend on the importance of the local isostatic compensatory uplift. It is unlikely that any one erosional cycle will run its course uninterrupted by base level changes induced by either tectonic or eustatic causes. Positive moment of the base level associated with the accelerated elevation or aggradation. It involves the submergence of the lower or the old stage of the river cycle. The result is the aggradation work done by the stream which results in the formation of buildup of the floodplain, which is the result of the backfilling of the upper valley and have effects on the stream gradient. It also forms deltaic outbuildings. All these features gives it an appearance of an old stage of valley. Mississippi River is an example of such river system. There may be other causes of aggradation which include uplift of the source area, increase in the debris supply when a certain tributary flush its water in the main stream, due to change in the climatic condition and due to various response of the basin due to wide range of complex changes superimposed on the drainage system. Negative movements on the other hand is associated with renewed erosion. It involves rejuvenation of the landforms, bringing youthful characteristics in the older stage. It may have steeper slopes, headward cutting with waves of incision and planation. It first affects the outcrop of the softer rocks and then works on the harder outcrops. It is marked by steeper slopes, terrace edges, nick points on river courses. The river course produces a kind of valley-in-valley feature also called multi-cyclic or polycyclic feature. Because of the negative movement rise in base level, the peneplain gets dissected. Sometimes the resistant outcrop rocks gets preserved and acts like summit peneplain remnant. In the lower terrain too, we can observe less resistant outcrop on partial peneplain. Sometimes the marine erosional surfaces are confused with the stripped plain pediments or exhumed peneplain. Now the dynamic rejuvenation. These are the changes brought in the cycle of erosion due to epeirogenic movements, that is tectonic movements. It may include upliftment of the landmass accompanied by tilting and warping, lowering of the outlet and the volcanic activity. Dynamic rejuvenation involves upliftment of landmass. Such movement can be caused by local orogenic movement. When the river is in its old stage, nearing its old stage, and the landmass on which it flows uplifts, the cycle gets interrupted and rejuvenates. The process of the rejuvenation can change a peneplain landscape, which has attained profile of equilibrium and were aggrading to revive their erosional power and engage in the process of valley deepening. Sometimes on the pre-existing peneplain, V-shaped valley, which is typical of a youthful stage, may appear, and the existing cycle would not only retard but a new cycle of erosion will begin. We may see remnant of the old cycle in the early stages of the new cycle of erosion, especially near hill and plateau tops, and on the broader interfluves. By the stage of late youth, the old peneplain will be visible as summit heights. But by early maturity, the renewed onset of effective divide wasting will cause the peneplain to disappear altogether on the landscape. Most peneplain in the British Isles take the form of hilltop surface and are so fragmented that they are by no means easy to identify, let alone interpret accurately. Their existence, however, is more readily inferred from an analysis of detailed topographical maps. Tilting of land and warping. Tilting of the land and warping or faults of the river basin will steepen the gradient of the stream that lead to the increased down cutting with more transporting power than the required. When there is a seaward tilt, its effects are noticed along the entire course of stream, as it is rejuvenated and is reflected in the deepening of the valley, especially in the stream where the direction of the course is parallel to the direction of the tilting. When the tilt is at the right angle to the direction of the river course, it will respond to the rejuvenation only after the joining stream deepens its valley so as to leave the tributary out of adjustment, even if the effect is only felt at the mouth of the course. Next is lowering of the outlet. The mouth of the river or where the river drains is the outlet. As the outlet is lowered, the river rejuvenates and its velocity increases. Higher velocity leads to higher degree of erosion and downcutting. If the outlet of the river is a lake, then the level of the lake is its local base level. If this base level suddenly gets lowered, then the outlet gets rejuvenated at the mouth. The river suddenly joins the lake descending abruptly, leading to downcutting, which is typical of youthful stage. Did you know Niagara Fall is an example of the lowering of the outlet, where the water falls from Niagara and is drained into Lake Erie. It is the condition with the river course having youthful stage at its mouth, nearing the lake, and old stage and topography at the higher side of the valley. Next is volcanic activity. Volcanic activity can cause accidental flow of lava in the valley, which may interrupt the normal cycle of erosion. Blocked by lava, the river will try to erode the obstacle by intensifying the erosive activity. If the lava flow engulfs the entire valley, then an all new cycle begins on the volcanic surface. Now, eustatic rejuvenations. Processes which results in the worldwide lowering of the sea level and is not related to the local changes happening to the base level. The eustatic changes can be produced by a decrease in ocean basin capacity as a result of the formation of the mild oceanic ridges. These can be of two kinds: eustatic rejuvenation. Number one is diastrophic eustatism, when the change in the sea level is due to the change in the capacity of the ocean basin. It is called diastrophic eustatism. According to Bollig 1935, who is proponent of diastrophic eustatism, he recognized glacio-eustatism, but gave more importance to diastrophic eustatism, stating that there is evidence of the worldwide lowering of the sea level during the Paleocene and Pleistocene, which was of far greater magnitude than possible changes made by glacio-eustatism. According to him, it was the result of epeirogenic movement associated with orogenic movement and not independently orogenic alone. Second is glacio-eustatism, when there is a change in the sea level as a result of withdrawal of water in the ocean, which was earlier accumulated in the form of ice sheets and glacier, is called glacio-eustatism. During the glacial period, the sea water gets stored and locked up. As a result, the sea level falls. Fall in the sea level leads to upliftment of the land. Climatic interruption to the cycle of erosion. The interruption to the cycle, which has already been discussed, is either caused by structural or the earth movements, or by eustatic changes of sea level caused by either glacial accumulation or through diastrophic movements. Many times streams that shows characteristics of youthful stage starts by eroding vast volume of unconsolidated glacial depth. Such a heavily loaded stream, when spreads in the lower level, they start to deposit these sediments. Over a period of time, the stream has lesser load. So, the river requires less energy to transport the load and more energy is used for vertical erosion. This may have evolved neither upliftment by diastrophic movement nor eustatic lowering of the sea level. Such interruption is called static rejuvenation. Static rejuvenation of the river course involves increase in the discharge of the river, which is caused without any upliftment of the base level nor lowering of the sea level, but because of the climatic changes. According to Davis, the climatic changes have tremendous effects on the normal cycle of erosion, and in certain circumstances, climatic effects on the erosion would totally change the course that is outlined in the normal cycle. Increase in the precipitation is usually reason for the increase in the volume without having increase in the load. The stream in such situation is able to carry load over more gentle slopes. As a result of the decrease in the load as compared to the runoff and subsequent rise in the stream volume also through acquiring the new drainage because of the diversion of derangement. This kind of rejuvenation was common during post-glacial times, when the river valley comprised of large volumes of glacial outwash. It is debatable that only increased rainfall is the only reason of increased stream volume. Many times, rejuvenation also occurs due to capturing of one drainage system by another. This is also called river capturing. Diverting water from captured river to captor river. Ohio Valley is an example of this version, as before heading to southeast Indiana and southwest Ohio, Ohio Valley had much shorter stream, but later including that of Kanawha, Monongahela and Allegheny. Denudation work in any region is greatly influenced by the climatic regime of the region. Climatic conditions like glacial and arid climate greatly influences and modifies the normal cycle. Davis termed these imposed modification as climatic accidents, but it is very difficult to find any remnant of the cycle of glacial erosion, since on the present landscape there is only one, that is the Quaternary glaciation, which have left any mark. It occupied a period of only 1/2 million years. Glacial erosion can show their effects on the upland area or the youthful stage of the cycle, which is indicated divisions view of irregular profiles with basin steps. But its old age glaciated landform is difficult to recognize, but its effect on the heavily glaciated lowland such as the Lutrinian and Fennoscandian shields can be easily regarded as glacial peneplains. But it is also known fact that these old peneplain surfaces were produced under a very different climatic conditions of a very geological time scale. This has been preserved over a long period of time under layers of deposits. This was exhumed by present day erosion, slightly modified by the Quaternary ice sheet, when arid climatic conditions are totally different from glacial, and so are the desert landscape. Desert landscape appears after several periods of desert cycle run in their full course for a considerable long period of time over the surface of the earth. It must be noted that the areas which were arid and semi-arid today were not necessarily arid in the past. They could be humid and even humid temperate climate. Desert erosion was particularly active in Permo-Triassic times. In the British Isles region, it may have escaped submergence by the chalk sea, but as envisaged by Davis, the arid and semi-arid cycle is more normal than the humid condition over a long period of time on the surface of the earth. Davis therefore also realized the need to form a separate cycle of desert erosion. Now we will talk about rejuvenated landforms. First is uplifted peneplain. Due to various reasons, the level of the peneplain gets uplifted higher than the present base level. This makes peneplain come to the second cycle of the erosion. Various factors can give evidence of such upliftment like peneplain's accordance with the summit area and the interstream levels, topographical unconformities, truncation of rocks of varying resistance, presence of the rocks with varying resistance to erosion, presence of layers with weathered rock debris and evidence of remnant of former alluvium. Second is nick points. Sometimes in the long profile of the river, there is a break due to fall or lowering of the base level. Rejuvenation causes the renewal of the down cutting along the long profile of a valley. When this valley intersects the long profile of the other valley, nick points are formed. It is the starting point in the formation of the river terrace. Third is river terraces. When the river starts cutting downwards and reaches a new base level, river terraces are formed. They represent valley floor abandoned by the rivers. As the streams get rejuvenated, it abandons the old valley and starts cutting the new valley's base level. It's like cutting second valley inside the first valley and develops a second valley, flat inside and below the first one. Sometimes terraces may appear at entire range of different heights on either or one side of valley. Such valleys are called paired, that is with same height, and unpaired, that is with different heights. Fourth are spurs and benches. When after rejuvenation, valleys have deeper cutting and which leads to the formation of terraces. When the tributary streams join the main river, a series of spurs are created which actually represents the valley floor of the old system. Refer to figure 4 for this, which shows interlocking spurs in pentaland. Fifth is incised meanders. Meandering of a stream over the floodplains is rejuvenation. It can cut gorges and canyon into old meander because of the extra erosional capacity while still retaining the meandering form. These are called incised meanders. This brings me to the end of this module. Thank you very much.